Ah, that glowing amber check engine light. We've all been there, right? But when your code reader spits out a cryptic number like P1128, it can be, well, pretty frustrating. But hey, don't worry, you are in exactly the right place to get this all sorted out. So if you're a Jeep owner and you're staring at this exact code, we're going to break this down step by step. The goal here is to turn that confusion into a crystal clear action plan. Ready? Let's dive in. Okay, first things first. What in the world does P1128 actually mean? It's not just some random number, you know? It's a very specific message your Jeep's computer is trying to send you. The key phrase here is closed-loop fueling. Now think of your engine's computer like a chef who's constantly tasting and adjusting a recipe. In closed loop, it's using feedback from all its sensors to get that air and fuel recipe just right. So this code, P1128, is basically the computer throwing its hands up and saying, hey, I'm trying my best, but I just can't get this recipe.
So, if the recipe's wrong, what's messing up the ingredients? Well, before we even think about replacing parts, we need to put on our detective hats and look at all the possible suspects.
Whoa, okay. I know this list can look a little intimidating, but don't panic, we are not going to just start guessing. We're going to follow what's called a diagnostic funnel, starting with the simplest, cheapest, and most common issues first, and work our way down this list in a really logical way.
All right, every good investigation starts with the easy stuff. Before you break out any big tools, let's just do a simple visual inspection of the engine's nervous system. You know, the wires and sensors that feed it all that critical information.
Our prime suspect, number 1 on the list, is the wiring for the main oxygen sensor, also known as sensor 1-1. Think of this sensor as the engine's master taste tester. It's sniffing the exhaust and telling the computer exactly how that air-fuel recipe turned out.
And look, you don't need to be a master mechanic for this part. Just grab a flashlight and get a good look at the wiring that leads to that first O2 sensor. See anything weird? Any melted plastic or maybe some frayed wires? How about some of that green, crusty corrosion on the connectors? Sometimes, believe it or not, the fix is as simple as cleaning a connection or fixing one little damaged wire.
Okay, if the O2 sensor wiring looks totally fine, our next check is the manifold absolute pressure sensor, or MAP sensor for short. Let's see what this little guy does.
Basically, the MAP sensor tells the computer how much load or stress is on the engine, which is another key piece of that fuel recipe puzzle. So, find it and just give it a quick visual once-over. Is it cracked? Is the electrical connector loose? These simple checks can save you a world of headache later on. All right, the final check in our initial sensor sweep is the engine coolant temperature sensor, or ECT. Now, this one might seem kind of unrelated to fuel, but trust me, it's absolutely critical.
The ECT sensor's job is to tell the computer if the engine is cold, warming up, or at full operating temperature. And just like a chef uses a different technique for a cold oven versus a hot one, your engine needs a different fuel mix depending on its temperature. If this sensor is lying to the computer, the whole recipe is going to be off. So check it for damage, make sure its connection is nice and snug.
Okay, so what if all the wiring and sensors look perfectly fine? Where do we go from there? Well, we've checked the information coming into the computer. Now it's time to check the physical delivery system for one of our key ingredients, the fuel itself.
Our path here is super logical. We start with the fuel line itself, looking for any obvious kinks or damage. From there, we move back towards the fuel tank, thinking about things like a clogged strainer or a worn-out fuel filter. And finally, we look at the heart of the whole operation, the fuel pump module. See, we're just systematically ruling things out, one by one.
So, what happens if the wiring is perfect and the fuel system checks out completely? Well, sometimes the messenger itself is the problem. That O2 sensor can actually fail, even when all of its wiring looks pristine.
And this is a really important point. We don't just jump to replacing this sensor right away. We only consider it after all our other simpler checks have come up empty. This is how you avoid just throwing money and parts at a problem you haven't actually figured out yet. We've now reached the very, very bottom of our diagnostic funnel. This is the absolute last resort. If everything else, and I mean everything else, has been ruled out, we have to consider the powertrain control module, or PCM.
The PCM is that main computer we've been talking about this whole time. It's the brain of the entire operation. Now, a PCM failure is pretty rare, and it's an expensive fix, which is exactly why it is dead last on our list. You only consider replacing the brain after you've confirmed that the body, the senses, and the whole circulatory system are working perfectly.
So you see, by following this structured process, from simple visual checks to the fuel system, and then finally to the big components themselves, you've transformed a vague, frustrating code into a totally manageable checklist. You have taken control of the situation. You know, this quote from the source material really says it all. The goal isn't just to fix the problem, it's to do it smartly, to do it without wasting your time or your money. This diagnostic funnel, well, this is that right knowledge.
So now you're armed with a complete roadmap. The power is back in your hands. That check engine light is no longer a mystery, it's just the start of a proper investigation. The only question left is, where are you gonna begin? Good luck with the diagnosis.